Welcome everyone. It's great to do this in front of a live audience. Normally I'm online behind my machine, so it's great to have people live. There's also people joining, hence the camera. People are joining online as well. So today we're going to talk about probably the most asked topic on the Python side, is that how do I use NumPy? Everybody's asking, so here we go. Go on back. So I'll just start with a quick agenda, do some Q&A from last sessions, explain how it works, the embedded Python interpreter in NX versus the external one, a little thing about Python versions to get it all to work, and then we'll dive into how you set it up to use the external interpreter. It's really not that difficult, and then I'll be showing just some general examples and give you some ideas what you can do and how you can make it run. I'll do that live, so hopefully everything works. And then if you want to have, there'll be maybe questions, discussions. So I've booked a brain date after the session directly. And I'll just go there then afterwards. You can follow me if you're interested to continue discussion. And that's there in Hall C. We go back to the brain date lounge. And then we can have continue the discussion. So some typical questions. Yes, everything will be recorded and everything will be shared afterwards. Also this presentation, so the links in here should work, so you can just click them or at least have access to the presentation. Some questions about TK Inter. I'll do that in the end as one of the future topics. For next session, maybe Q3, somewhere September, probably it would be. The biggest hurdle, I think, in NXOpen, doesn't matter whether it's Python or any other language, is how do I get from find object to the rest, to all objects and get that going. So that's explained in the NX documentation. There's a getting started with NX, and that it explained how you can get from find object to actually getting your lists of all the objects, so you can access them, search through them, and find the one you need without having to hard code the journal identifier in there. It's also explained on my Udemy course, the beginner Udemy course. If you prefer to see it and being walked through, then it's a bit easier. I made a coupon virtual event June 26A. So if you want to join the course. Questions on performance of Python versus other languages. Python's a scripting language, so theoretically it's not as fast as the other languages, but we're executing through NX, and typically things take longer there on the NX side to display stuff, update stuff, find objects, have NX display. So most of the time it's not an issue, and if it is an issue, if it's really an issue, very often you can already do something in the code to let's say, improve your performance. Instead of having an array and just adding items to the array all the time, you can also declare it in advance, have the full array declared in memory, and then dump it out. So that's a few standard tricks which typically make it a lot faster. In case you really run into performance issues, like I have to do this, then yeah, I'm afraid that you'll have to switch to another language, but then probably you'll end up in C++ or C# anyways to make that happen. But most of the time, I haven't really run into issues or cases where it's really an issue. Debugging, there's also now recently in the later NX versions, there's also in the documentation a section on debugging, and I also cover it very briefly in my advanced course. So if you're interested also, you can really walk you through, you can see it there as well. I think I've got some more Q&A questions. Yeah, so there's a batch in Linux as well. So if you want to run batch workloads on Linux, that's possible. That's a special install, NX install, which is especially for Windows. But you need a special license to actually run NX on Windows. So if you need that workload, it's best to talk to your Siemens representative and see how you can get that to work. From Team Center, in essence, it's all the same except for opening and closing parts. So opening your parts is obviously different in Teamcenter. The rest is the same. To be honest, I'm not really familiar with Teamcenter much, so I've tried to postpone it, but at some point I think we'll have to do a session also like specifically for Teamcenter, so we can see like what are the specific cases where we need Teamcenter. And then also in the previous sessions, I have shown how you can use the stub files to get IntelliSense going while you're programming in VS Code. The UF functions are still missing there. If I have some free time this summer, I'll see if I can work on them so they can actually integrate with the ones from Siemens and then distribute them so you can just copy them in, and then you will have the IntelliSense for the traditional UF functions as well. But I'm working on that still. So now going to the actual topic. What we have is in essence, we have two versions. We got the embedded Python shipping with NX, and we got the external interpreter. Those are like the two modes that you can run Python in NX. The pros of the embedded Python, that's just your standard NX, and is that, well, you don't have to install anything. You don't have to install Python. You don't need to do anything. You can just run Python code as a journal, and that will work out of the box. You can even like import functions from sibling files. If you have like a module with functions that you define, you can just, if they're together, you can just import them, and that just works out of the box. The downsides there is that there's only plain Python. So in essence, you have access to the sys package, OS package, time, and import lib, and some other even more obscure and really not less relevant packages for a user. So that's why we're here today, is that there's no special packages. So you cannot use NumPy, you cannot use pandas, OpenPyXL, matplotlib. So all that kind of stuff is not going to work with the embedded version in NX. Then there's the second option, and that is where you install Python on your machine, and then you point NX to use that Python version instead of its embedded Python interpreter. And from that moment on, you can actually use, the NumPy, pandas, whichever package your IT department allows you to download. It does require you to install Python separately on the machine. You need to match your Python version with the one in your NX version. So if you sometimes upgrade, the Python version might change, so we will have to have a new install or a new Python version installed. I'll go through that later. And you need to do some configuration of NX itself. But we'll just walk through that. It's really not that difficult. Just going back on the Python versions, I have some I knew, I don't have them all. But for example, NX12 was shipping with internal Python interpreter 3.6. The latest one, 25.12, is shipping with Python 3.12. The major, or the major release is important. The 3.12, the point release is not that important, but the Python version that you're going to install on your machine has to match the one in NX. And I'll show you how to actually get that for your specific NX version. I have it here. You can just run sys.version and it will print your NX, the Python version running in your NX installation. So I think I can just show that here. I got that one ready. So I got another one where I just do a basic NumPy check. So that's the test external interpreter. If I run this one, you will see that there is no module named NumPy. So, and that's what most people have run into in the past. In this case, NumPy is installed, but it's just not finding it. The first step that we want to do is we want to install the right Python version. And I would suggest to avoid to use the Microsoft App Store one. Not very good experience with it and build control. So normally I go to python.org. Yeah, then you can go to all downloads, And basically, if you scroll down a bit, you can go to all releases, and there we can find our 3.12.11. Sometimes you will see that it's superseded, so there's no real download section there. If I now go to 3.12.13, it's still not working, but here they say that it's basically 3.12.10. So what I do I just try to follow the releases and find one which is close. Like what I mentioned, the main importance that it's 3.12. The point release itself is not that critical. So if we go back, one more, sorry. Yeah, 3.12.10, it's that one. And then we can download, and you can download them all for your system. So that would be the Windows 64-bit installer for most people nowadays. You can just install it, run it, accept all the defaults. Just make sure when you see the check mark to add it to path, so that when you run Python, it's actually just from the command line, it's on your path, so Windows can find your system. Nothing special there. Sometimes you do have two options. You can install it for your user, and then Python will be installed in your app data. If you install it for all users, it will be in C program files. Just be aware of that you might have to look at two locations where it's installed. That can be tricky. But apart from that, it's just the location where to point to. So that's step one. The second step is then we need to set some environment variables. And for that, you have two options. Let's say if it's for your users and you're pushing to your users as more from an IT standpoint and a deployment, you can use the environment variables. So either the system ones or the user ones. And then you can define them here as environment variable, and then they're like system-wide for your system available, and you can just start NX normally because NX will then pick them up. But in this case, I will show you it's a bit more clear how you just define them in a command file and then just run NX from a command file. This is also explained in the documentation nowadays for later versions of NX. I'm not sure when it started. I think like 23, 24 maybe that it started being added, like how to do that. And these are basically the set of environment variables that you need to set. So you got the default UGII based here. It's the standard installation. And these are then the specific Python ones. There's a UGII Python DLL, where you point at the DLL, just the name. So in this case, 3.12. For your version might be 3.11, 3.10, I guess up to 3.6 if you're still on 12. UGI Python home, and it's either C user your username app data if you installed it for a local user, I think, which will be mostly the case because that's on let's say a corporate system you're allowed to install as a user but not system wide. So most of the times it will be username, app data local, then programs Python 3.12. There's also a library there, which is basically the same folder. And then a whole set of Python path folders that you need to list, which need to be on your Python path. First of all, the Design Center install one. So your NX bin Python from your NX installation. And then the rest of them are just, again, to your Python installation. So under app data, the basic, the root folder from Python, the DLLs, the libs, the lib, two different things. And then also the side packages. And if we set all these environment variables, either as system-wide environment variables or in a command file, and we start NX, it will pick up our installation. And then we got two optional ones, but I typically add them in already anyways. These are the TCL library and TK library, and you need those if you want to do TK inter, which we might be doing in one of the future sessions. But again, same location, users, Python, and then TCL 86, and the other one. Yep. So if we do that, I'll show you my startup file. There's no secret there. So UGI Python DLL and this whole set. I like to use this, I'm not sure, I don't know the English name for it, accent circonflexe in French. So we can actually easier see what directories are there. Otherwise, it's one big line, and then it's a bit harder to see. The two TK library ones, and then the rest is just user dir, base dir, user dir, but those are the standard sessions, and then my dongle license and license server. So that's it. If we now go back, let me close it off. So you do need to restart NX to have these environment variables pick up. So this is one. So that's the file you just saw, just a copy of it. It might take a minute to start up. Let me start a command prompt in the medium as well. Let's go back to the presentation in the meantime. So then you have it pointing to your external Python installation. And then if you want to use packages, it's the standard pip install. And it will point it to your global system installation. So they all install, if you install them globally, we're also pointing at the global one. So then NX will find them at startup. One thing to notice, one special one, is that when you're using things like Python, which like shoot off threads or something similar, I don't know the details well, no, I just don't know the details. But if you don't have this in your first 3 lines, NX will seems to run it differently. When you use NumPy, you'll get an error. So that's also, it's documented in, so it's in the Simian's documentation explaining that you need it, not for every package, only for the ones who like kick off other threads. But I tend to just, when I use the external interpreter, I just tend to copy it in, and hasn't been a problem for me. And then, yeah, that's actually the error you'll get. It says cannot load module more than once. So that's, I can give you a quick show of that. And then as a test, I'll just do import NumPy and just print the absolute value of 10 using NumPy instead of standard Python. So I think it's loaded by now. Let's see. So we can run this again. Fingers crossed. There we go. So basically it's the same script. Python 3.12 again, and here you see that NumPy is actually working. So let me do this quickly. I started the commands. No, the other one. So let me just uninstall NumPy and show you what's going on then. So what we see, it cannot remove everything because it's loaded by NX, so it's holding some files up. But if all goes well or not well, no, still loaded. I'll need to restart it, sorry. So it was still holding on. It loaded NumPy and it's still new NumPy in the session. So I really have to shut down NX and try it again. Yeah, I'm sorry. I'm on my slow machine, so this might take a while. If there's any questions or anything like that, just shout. For the people online, I think Pat's, is it Pat who's online? Jeff will also be answering questions. Oh, it's okay, Taryn. I don't see any questions right away. Try again. Oh, no, I need to click the right one. There we go. That's what I wanted to show. So no more NumPy available. And I thought this one did work. It shouldn't take too long. Shouldn't take too long. Alrighty, there we go. Let's try it again. Yeah. So now it's back on. So, and basically that's it. There's not much more to it than that. And now you're free to use external Python packages, whichever one you want, using standard Python functionality. One more thing, which sometimes happens, is that you get a TCL error saying that the versions are mismatching. This is a community post where it's explained how to fix it. It's basically update the number in the file and it's gonna work in 2 files, but it's convenient to know that it's there and how to fix it. Makes it life much easier. And then I just want to show a few hopefully fun examples. Some cat facts, NumPy Open 3D, multiple threads. NX does not like multiple threads, so don't get your hopes up. And just a little bit about it. I'm not going to show anything about Excel itself, but just I'll talk a little bit about that later. So basically the the cat facts make an API call to a URL and then show it within NX. So I'll show you the code of that one. It's quite simple. Cat facts, what is it here? NX threaded, for sure. We got the async IO stuff, so it's going to need NX threaded. Import NXOpen, all the sessions. This is all just some ASCII string for fun. And this is basically the code. You have a URL, you do a get to the URL, you get a response back, and you print the response to the listing window. Nothing exciting, and then just run it. So what do we get then is hold on. We get a cat fact. So that's my ASCII string I defined earlier. That's actually coming from the internet API, which is cats have supersonic hearing. I can run it again, and then I get another cat fact. So long-haired cats are just a recent thing. Just to show you that it's really nothing more than an API call. That's the API call. It's just basic API call, nothing special about it. And if we rerun is the same as refresh, we get new values. So API calls. One I did then, I thought with the cat facts, oh, that's okay. Made an API call and printed it to the listing window. Okay, very basic. One a bit more of an update is actually, I will actually now interact with NX, with the cat system. And so let me open. So I got this text file prepared already. It just says text. Give it a minute. Voila. Oh, wait, no, it says hello world, obviously. What I'm going to do now is, like, when I make the API call, I'm going to update this text with the cat fact. So developer play NXOpen cat facts update. Voila. Something with Cheshire Cats and Lewis Carroll, Alice in Wonderland. You can run it again, and it updates. So this is a fun gimmick, let's say. I do find it very powerful. Let's say you have company technology, company IP, company calculations that you do not want to share with either your employees or contractors. you know, the typical Excel file, and everybody use the Excel file, and then every employee, when they leave, change employers, they take the Excel file with, and all your knowledge gets all over the place. So what you can do is you can put that knowledge behind an API, and then you can call that API, and you actually protect your IP from from being seen by everyone, and everybody can still use it, the calculation. They just no longer know what's behind it. That's, I think, an A use case for something like that. What was my next? Yeah, so that's what I was trying to say. So your company logic is outside of NX also. Like, let's say you could also do complex calculations in your NXOpen, but then you will actually run it through NX. I need to have an NX license to run that calculation. You could also do the same calculation, split it out of NX, or run it in API, and then you can reuse that same calculation in NX, but maybe in an Excel file in something else. So you can like split your logic and your reuse. So you also only have to program it once. Otherwise, you need one in VBA for Excel, you need one in NXOpen for NX, and then you get the update versions. And there's no NX logic in there, then I think there's no point in keeping it within NX, and it can be handy to split it out. Then another one, it's NumPy and Open3D. It's not fast. I'll give you a heads up already. Just close this one out. So I've got this example of 2 cubes, 2 boxes, and 2 cylinders. And now we can actually run Open3D with NumPy to do an, what's it called? I believe it's called SVD, where you can actually take 2 bodies and see if they're identical, however they oriented in space. So what we do then is from the geometry, let's say in this case, I export the step file, the STL file. So you get points on the geometry, and then you can run the Open3D on those points, and then you can get it back and identify which bodies are equal. So in this case, it's an identify copies. This is not optimized. It already takes quite a while on these little files. So yeah, it's more of an example what you can do than really a functional thing. So now you see you got the 3 checks and then the 3 groups. And basically, I love colors. I just colored them. Each block which is identical has the same color. So that's NumPy and Open3D as an example. I'm gonna show you one for multiple threads, just so you know what happens when you do. I can just run it, I think. I got a multiple thread example. Let me show you the code first. What is it? Thread example. So it's basically defining 2 tasks, running 2 tasks in a thread, and then joining them again and waiting till they're finished. Nothing spectacular, but it's going to be this one. Oh, let me rerun it so it's a clean list. So you get these warnings from NX that it's going. So if you're firing something from a second thread, you'll get one of those warnings every time the thread runs. So it's going to be very annoying very quickly. That being said, in theory, you can run something on a different thread as long as it's not interacting with NX. So if you're not doing anything with NX, like, I don't know, reading bodies, changing bodies, but doing something completely different, you could use that in a thread, but you will still get that to go. In that case, I would probably also, if it's nothing to do with NX, I would say put it behind an API call, run it there, and just make the API call. And then you don't have to do all the threading and all the complexity involved. It can just be simple fire or like request response. I just wanted to show you that what happens when you run a thread. And then, yeah. And then the last, then the last one, I don't have any examples for Excel interaction. Nothing to do with NXOpen or NX really, but just bear in mind that you have Excel the program and XLSX the file. So if you're reading an Excel file, XLSX, let's say using OpenPyXL or pandas, you can read the file. You can also change values in the file, but those values will not update according to the formulas. Those formulas only update when you open the file in Excel, the program. So you can use OpenPyXL to just read Excel files, write data to Excel files, but if it has like engineering logic inside of it, and the Excel file needs to update, like you write something to the Excel file, you want to update it value from the formulas, then you actually need to use Excel Wings, which basically starts Excel up, and then you interact with Excel over COM. So then you have that functionality. I learned that about a few years ago. Been using Excel all my life and like thing, and then like, oh, those are different. So just a heads up there. I think that's about it from my side. I'm gonna finish early. Oh no, I wasn't. I still have some things. So you can use those NumPy, pandas, OpenPyXL to use them. Use them. Don't write your own logic. They're there. So why would we bother using that? They're much better done than what can we do. But those packages also allow you to reuse your code. And the easiest to start with is what I mentioned earlier, even in the standard embedded interpreter, that if you have a module file with basic functionality next to your, let's say, application Python file, you can import those functions. And if you then put them on a, let's say, a network UGI user dir, you can also push that code and update that code, and that just works fine. And I think for a lot of use cases, that will work fine. The next level up is then that you can also build your own package. So just like NumPy, you can build one for your own company, you can install it, and then you can also start using it as if it was a standard package. The downside of that is that you need to build it, you need to install it everywhere, and you need to manage your versions. Well, here you also already need to have version management, but it can be a bit simpler. And to show you an example, I've made one called NXOpentse. It's available public on PyPy. So you can just do a pip install NXOpentse. I welcome contributions. We can just use it. And I'll show you a quick demo of that one. Just quickly go through the codes. What is it? I don't see it right away. I thought I had it. Oh, sorry, there. So basically it's the same thing, the standard Python. You import the package as TSC. And from that moment on, you can just use it. So you can call get all features, which is defined in the package. So it will give you a list of features. IntelliSense works, so it's, you know, you see what you have an optional work part to give it, and then it returns you a list of features, and then what you do with that is up to you. Get all the bodies in the part, get the faces of a body. These are rather simple functions, like they're like 2 or 3 line functions, so they're not that complex. But especially for, let's say, if you have less experienced users, they can use that to really quickly get started without having to know all the ins and outs of NXOpen and builders and all that kind of stuff for more complex ones. For example, this one, I just defined 2 points, and then you create a line between the 2 points. It's not perfect. You can also define a function where you can create a cylinder between 2 points, where the 2 points only give you the direction of the cylinder, and you still have a length as a parameter of that cylinder, so you can get a cylinder in space. And for example, this one, you can get from that cylinder 1, I make 2 cylinders, and then I get the cylinders from cylinder 1, and I add them into bodies. and then I can create a bounding box around the two cylinders. For example, the create cylinder and the create bounding box is quite a bit of code already. You can shield that from your users or for yourself also, just reuse it and make that available. And if we now run this, we'll just do a new file. Oh, hold on. Let me make this a bit closer. I can just... It's not going to work. Sorry, let me open a new one. So you can actually see what's going on. So it creates a line, but it creates the 2 points, the line between the 2 points, the 2 points in space, and the 2 cylinders in between, and the bounding box. So that's how you can, let's say, use your own package. And then a small thing for people developing the packages. You'll have to install it locally, pip install e-dot. And then you also need to make sure that your Python path in the NX environment variables, that you add the side packages in that one, and also the virtual environment itself. So when you run it as a developer, you can find it easily. That's part of a consequence of the local install. And then also import lib. You might have noticed that when we ran the simple cat facts the first time, it took a bit longer than the second time. That's because NX only loads it the first time it's used, and then the second time it stays loaded, so it runs faster. That also means that because it stays loaded, if you're developing and you're making changes, those changes do not come back unless you shut down NX and restart. What you can do there is you can use import lib to programmatically reload your own package, so you don't have to restart NX all the time. Just a convenience thing, but if you're doing a lot of changes and testing it, it can be very handy to do that. You can leave that for later. I got some contact information, links to the courses, but those will be shared then when we share so you can find the links back at a later time.
That's good. Yeah, for our online viewers, we do have the few questions. They've been recorded there, and we will take care of those at a later time to stay on schedule. Thank you, everyone, for joining us today, whether online or in person.
Thank you, everyone.